I use this relatively old Sharp portable computer, the PC compatible, partly because it's electrically quiet, doesn't cause me interference problems for contest logging, and also because it has a relatively small, full-size but small keyboard that doesn't take up a lot of space on the desk. It's I suppose I should say it's a portable. As someone once said of the Osbornes and the K-Pros, they're portable in the same sense that a 30-pound bag of bricks with a handle is a portable. I use an auxiliary CRT display simply for visibility, and PC Plus communication software, or Procom Plus, I'm sorry. Okay, now we're ready to go. Now I've zoomed out into a lower working corner of the screen where I can blow this up for better readability, and we'll start from scratch. You can do this, remember, we could do this, and it has been done, over a 1,000-mile telephone line or more. It's been done by radio, and of course I'm using a local computer. Okay, let's turn the power on. Whoops, that's the wrong message. AC on, return. Power on sequence. You can press. After the initial amplifier warm-up time delay is completed, this message has come up showing us the status of the amplifier. It is on 28 megahertz, which has been band 9, segment 1, of course, because it's the bottom end of the band. It's 28010 or 28020. And the tune and load numbers give an indication of the position of those variable capacitors. This is useful for various automatic control purposes, for automatically tuning up these amplifiers, programming them in our lab, and so forth. You'll notice it also tells you that the antenna connected is antenna A1. That's because I'm still using it with the Digital Antenna Selector, and that the state is operate. Now if I want to operate the transceiver alone, barefoot so to speak, I can remotely switch the amplifier into the standby state with the command operate off, return, and you see that we are in state equals standby. It once again confirms the adjustment of the amplifier and the antenna. Now back to the operate condition on the assumption that we want to use the amplifier. Operate on. We're back in the operate condition. Now suppose I'm not going to work 28 megs. Let's say I want to work 20 meters, 14 megs. There are two ways I can go there. The obvious one, I simply switch my transceiver. Now presumably it's also being remotely controlled if the amplifier is say on a mountaintop 50 miles away. Or if I'm in the station and have simply remoted the amplifier to a different location, I can simply put the transceiver on 14 megs, drive it. I'm just going to apply carrier for a moment, and it makes its automatic band change, and as you can see it switched to 14.2. Actually the transceiver is set to 14.202, and it confirms that that's band 5, segment 3, which is correct, and the position of the tune and load controls, which would be useful if I wanted to do any remote tuning to see where I am. And you'll notice the antenna has gone to the correct one, D4, and we're ready to operate now. Now let's suppose I want to monitor. I'm going to turn on the carrier and set it for a kilowatt. Now, how much output power is there? I believe this is the correct question. I don't have the complete list there. Well, 980 watts. That's a higher resolution answer than the LED bar graph is capable of, and if I want to adjust it up a little bit to a kilowatt, I can do that again. I could do that. If I want to know grid current, I believe I can just key in or type in grid, return. Grid current is 21 milliamperes, which is fine. Suppose I want to know what my efficiency is. I'm running 1 kilowatt, and I happen to know the amplifier is loaded quite heavily for somewhat higher power than 1 kilowatt, but just as a matter of curiosity, and since remember I may be miles away, let's find out what the plate current meter, what the plate voltage and plate current, the power input is. We'll compare that with the power output and see what our efficiency is. So the command for that is meter, because the metering function, you recall, has a push button, and I want to meter high voltage. Okay, the high voltage, 2354 volts, under load, 2354. Now let's meter plate current, IP, 1.11 amps. And let's, at this point, once again, determine what the forward power is. The output power, it's still 980 watts. Now I'm going to stand by while I do a quick calculation. So we have 980 watts, 2354 plate volts, 1.1 amps. The efficiency will be 980 watts divided by, using just a hand calculator, 2354. My calculator jumped. And also divided by 1.11, 1.1 amps. And that says that we are running about 2,500 watts in and have only about 38% efficiency. That's no surprise, because the amplifier should be properly loaded for the power level at which we're going to operate. Let's take the output power, apply power again, and set it for about 1,500 watts. I think, however, the amplifier probably is loaded too heavily for this power level as well. But let's see what we have. The power, 1445, take it a little higher. Okay, that's close enough to 1,500. 1,500 watts. The plate voltage is METER, high voltage, 2370. And the plate current is 1.37. Let's see what that efficiency calculates out to. We have 1502 watts divided by 2370 volts divided by 1.37 amps, and the efficiency now is about 47%. Still not very good, because evidently the amplifier is loaded for considerably higher power. I switched the plate meter to look at the tune adjustment and test it, and it is indeed loaded quite heavily from some of the previous demonstrations that I was showing you. So I'm going to manually load the amplifier more lightly. I could do it via the computer, but to save time I'll do it directly on the panel. I picked the tune indication here. Now drive it to a few hundred watts, and I'm going to reduce loading. You see the indication of the loading capacitor changing there. And I'm peaking I'm using the tune meter, and I'll show you the end result here in just a moment. Well, I overshot. Okay, that's approximately where I want to be, and that's what the tune meter looks like now. I'm dead on center, so the efficiency should be considerably better in the 1,500 watt range. Okay, so let's start over again now and see what I've raised the drive level now. Let's into the range of 1,500, 2,000 watts roughly, and let's see what we have. Carrier on. Power is 1837. The high voltage is 2451, and the plate current is 1.14 amps. The efficiency calculates at just about 66%, which is very good. That's a good normal operating efficiency.